Hey everyone, so today we're going to be solving multi-step equations. In these kinds of equations, we're going to see some combining like terms, we're going to see some distribution, and we're going to see variables on both sides of the equal sign. So it's pretty much everything that we've been doing has led to this kind of equation that we're going to see today. So because there are so many steps when solving these kinds of equations, this is kind of like a cheesy way for you to remember what order to do these steps in. So don't call me after midnight. That's one way to remember it. Where the D stands for distribute, so you're always going to distribute first. The C stands for combine like terms. Remember, that's when our like terms are on the same side of the equal sign. We never combine like terms over the equal sign. M stands for move variables, preferably the ones with the smaller coefficients. A stands for add or subtract constants, so using those inverse operations. And then M stands for multiply or divide. So most of the time it's division, but it could be either multiplying or dividing. Okay, so don't call me after midnight. That's one way to remember the steps in order. So for this first example, we have 4x minus 12 plus 2x equals 36 plus 2x. So like every other equation, how we want to start this is drawing those train tracks. And the first step is to distribute, but we don't see any parentheses here. So in this case, we are not going to distribute anything. So our next step would be to combine like terms. And like I said before, that means like terms on the same side of the equal sign. So on this side of the equal sign, we see that there's a 4x and a 2x, and we're going to combine those. Please note, we're not combining this 2x over here, because even though it's like terms with the 4x and the 2x, it's all the way on this side of the equal sign, and we cannot cross those train tracks. So we're only going to be combining these two. So let's go ahead and do that. 4x plus 2x gives us 6x. And then we're going to bring down anything we did not use, which was pretty much everything else. 2x. Okay, so we did that first step. Well, that second step, technically. Now we're going to move our variables. So we're going to take a look at the terms that have variables and which one has a smaller coefficient. So we have a 6x and we have a 2x. 2x is smaller, so that's the one that I prefer to move. And we're going to use inverse operations here. So it's a positive 2x, so we're going to subtract it on both sides. We're going to subtract it from the 2x, and we're going to subtract it from this 6x, because those are like terms. That cancels. 6x minus 2x gives us 4x. Bring down anything you did not use. Okay, so that was that next step, move variables. Now we're going to add or subtract constants here. Our constant is the number without the variable. So in this case, it's this 12. So we're going to add the 12. So we're going to do that in red. We're going to add the 12 to both sides. And I'm even going to just circle the fact that we're adding here. Okay, those cancel. 4x equals 36 plus 12 gives us 48. Now for our last step, multiply or divide. Here we're going to divide by 4, so I'm going to just circle that divide. Divide by 4 on both sides because that's what's next to the variable, and we don't want anything next to the variable. And we get x equals 48 divided by 4 is 12. Okay, so we did not distribute here because it was not applicable, but we did combine our like terms on the same side. Then we moved our variable. We moved our constant, so we added or subtracted that constant, and then we divided in the end to get that variable by itself. Okay, let's take a look at another example. Okay, so when solving multi-step equations, always distribute first, then combine like terms. So that's talking about these first two steps. So that's really, really important, is we have to distribute before we combine our like terms. So let's go ahead and start this question. We have 2 times the difference of m and 3 plus 8 equals 3m minus 8. So first, let's draw those train tracks. And our first step here would be to distribute, which is applicable in this case. So I'm going to take that 2, and we're going to distribute that to what's inside the parentheses. So that's that first step. 2 times m is 2m. 2 times -3 is -6. Don't distribute to anything outside the parentheses, and bring down whatever you didn't use. Okay, now let's reevaluate and combine like terms. So let's make sure that we can simplify if there's anything that can be combined on either side of the equal sign. So in this case, we see here that we have this -6 and this +8 are like terms, so we're going to combine those. The 2m is not like terms with these, so we're not going to combine, and these are not like terms, so we're not going to combine anything over here. -6 plus 8, that gives us a +2. Bring down anything you didn't use, we didn't touch, and keep solving. So we did that next step. Now let's move our variable, preferably the one with the smaller coefficient. We have 2m and 3m. 2m is smaller, so that's the one I'm going to move. It's positive because there's no sign in front, so we're going to subtract 2m on both sides. That cancels. Bring down your 2, bring down your equal sign. 3 minus 2 is 1, so it's 1m, but technically I don't need to put that 1 there, so in this case I'm not going to. -8, so we did that next step. Now we're going to add or subtract constants, and remember our goal is to get the variable by itself, so we want to move the constant that's next to the variable. So I'm going to add 8 to both sides. That cancels. 2 plus 8 is 10. 10 equals m. Now, in this case, there's that invisible 1 in front, but there's no other number in front. So technically, we don't have to do anything. This was our last step. We don't need to divide anything because m is by itself. It's isolated. It's positive. So this step does not apply in this case. So you're going to see that sometimes where you can use all the steps, or sometimes you can leave some certain steps out, just like we left out the distribution in the first one, and then we left out the divide in this step, because you can divide by 1, but you're going to just end up with 10 in the end, so you don't really need to do that step. Okay, let's take a look at one more example. So we have a lot of stuff going on here. Remember, we're going to just take it step by step and just remain organized, because organization is a really big part of math. So I'm going to draw the train tracks. They're going to be pretty long in this case because there are a lot of steps here. And let's see what we're going to do first. We have 4 times the difference of 2x and 6 plus 9 equals 3 times the difference of x and 7 plus 8x. So we do have parentheses, so we know that we are going to distribute. So I'm going to do both distribution at the same time because they're on different sides, so they're not going to affect each other. So we're going to we're going to distribute this 4 to what's inside this parentheses, and then we're going to distribute this 3 to what's inside of this set of parentheses. So 4 times 2x gives us 8x. 4 times -6 gives us -24. And I'm going to just bring down that plus 9, not distributing to that. Now let's distribute 3 times x gives us 3x. 3 times -7, treat that like a -7, equals -21. And then bring down this positive 8x. Okay, so we got rid of our parentheses in one step. Okay, now we're going to combine like terms. Remember, only to combine like terms when they're on the same side of the equal sign. So we're going to take a look at this side of the equal sign. We have 8x minus 24 plus 9. In this case, these are like terms here, so we're going to combine those, and we're going to get a -15. Now I'm going to bring down the 8x. And now let's take a look at this side of the equal sign. We're going to combine whatever's like terms on this side. So we have 3x minus 21 plus 8x. And we can see that 3x and 8x are like terms, so we're going to combine those, and we get 11x. And I'm going to bring down that minus 21. Okay, so it's okay if you do them at the same time, as long as they're on separate sides of the equal sign, because you can see it did not affect, whatever we did on this side didn't affect this side, and vice versa. Okay, so we did this step. Now we're going to move our variables. So let's move the one with the smaller coefficient. Go to red again. 8x and 11x. 8 is smaller, so I'm going to subtract 8x on both sides. Remember to subtract it from whatever it's like terms with. We're not going to subtract from the 21 because we're not able to subtract it because they're not like terms. These cancel. Get negative 15 equals 11 minus 8 is 3x, and bring down your 21. Okay, so that was the third step. Now we're going to add or subtract constants. Goal is to get the variable by itself, so we're going to move the constant that's next to the variable. Let's add the 21 on both sides. These cancel. Negative 15 plus 21 gives us a positive 6. Bring down this 3, not 32. It's definitely not a 2. 3x. And the last step here, multiply or divide. We are going to divide by 3 on both sides. 6 divided by 3 is 2. These 3's cancel, so we get 2 is equal to x. Let me just make that look a little bit more like an x. Okay. So we did these last 2 steps. So I'm going to just review what we did. We distributed whatever was right outside the parentheses on both sides. We did that in one step. Then we combined our like terms on both sets of the equal sign before we started moving anything around. Then we moved our variable, the one with the smaller coefficient. Then we added our constant here. And then we divided by the coefficient because we want to get x by itself. And that's it. So I know that it might seem like a lot of steps in one, but if you want to write this on the side of your paper, it might help keep you organized on what you need to do with each step.